Lesson 10.1, Right Triangle Trigonometry. Turns out that if you have a right triangle, there are always 6 ratios of sides that are constant. So, if we have a triangle here, notice this angle is the angle we're talking about, this one right here. So we have the hypotenuse. The side opposite the angle we'll call the opposite side, and the side adjacent to the angle we'll call adjacent. Sine, that's S-I-N-E, so of the angle is the opposite over hypotenuse. Now we always have to say which angle we're talking about so that we know which side is opposite. And for now we're just talking about the acute angles. Because if I don't say what angle it is, I don't know which side of the triangle is opposite. Cosecant is its reciprocals. This is cosecant. It's the hypotenuse over opposite. Cosine of the angle is the adjacent over hypotenuse, and again we have to have the angle so we know which side's adjacent. And secant is the hypotenuse over adjacent. They're reciprocals. And then we have tangent. It's the opposite over adjacent. And its reciprocal, cotangent, which is adjacent over opposite. So notice each one is a reciprocal with the one across from it, and the cos don't go together. Sine goes with cosecant, cosine goes with secant, and the cosine of theta equals cosine of the other angle. So sine of this angle here equals cosine of that angle up there. The way to remember this is SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent's opposite over adjacent. And then just remember the reciprocals. So let's try an example. Evaluate the 6 trig functions of theta. Alright, so the first thing we have to do is identify what all the sides are. So if I go across the triangle from our angle, that's the opposite. The leg touching the angle is the adjacent, and then the hypotenuse. The hypotenuse is always the hypotenuse. It's never the adjacent or opposite. The hypotenuse is always hypotenuse. Alright, so sine is the opposite over the hypotenuse. The opposite is 3. The hypotenuse is, wait, what? What's the hypotenuse? Well, we could use the Pythagorean theorem. 3 squared plus 4 squared equals my hypotenuse squared. That's 9 plus 16, or 25. So my hypotenuse appears to be 5. So sine is 3 over 5. Which makes cosecant, which is the reciprocal, hypotenuse over opposite, be 5 over 3. Cosine is adjacent over hypotenuse. The adjacent is 4, hypotenuse is 5. Its reciprocal, secant of the angle, is the hypotenuse over the adjacent, which would be 5 over 4. Tangent of the angle is the opposite over the adjacent. Opposite is 3, adjacent is 4. And lastly, its reciprocal cotangent is the adjacent over opposite, which is 4 over 3. So there we go. We have sine, cosine, tangent, cosecant, secant, and cotangent. Let's try another one. Looks like, again, we have to find the other side. All right, so what side is that? That is the opposite side. So I could say 10 squared plus the opposite squared equals 18 squared, because 18 is the hypotenuse. 10 is the adjacent. It's touching the angle. So we have 100 plus the opposite squared equals 18 squared, which is 324. Subtract the 100, you get 224. And then square root that. When you square root 224, let's see, what would that be? That is, it turns out to be 16 times 14. So the square root of 16 is 4. Square root of 14. Alright, so let's find all our trig functions. Sine is opposite over hypotenuse, so that is 4 square root of 14 over 18. Oh wait, we can reduce by 2. I can divide the top and bottom by 2. It should be 2 square root of 14 over 9. Cosine is the adjacent over the hypotenuse. The adjacent is 10, hypotenuse is 18. We can reduce that to 5 over 9. And then tangent is the opposite over the adjacent, which is 4 square root of 14 for the opposite, and the adjacent is 10. Wait, we can reduce by 2, so it'll be 2 square root of 14 over 5. Cosecant is the reciprocal of sine. It's the hypotenuse over the opposite. If you'd like, I am just reciprocaling that one. But I can't have a square root in the bottom. So I need to multiply the top and bottom by 14. So it'll be 9 square root of 14 over square root of 14 times square root of 14 is 14 times 2 is 28. So it's 9 square root of 14 over 28. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. So that's that one. Just flip it over, it'd be 9 over 5. And then cotangent is the reciprocal of tangent, the adjacent over the opposite. So I can just take that one and write it down here, but flip it over. Or you could have started from scratch and you get the same answers. You can't have a square root in the denominator. So on the top, I have 5 square root of 14. On the bottom, 14 times square root of 14 times square root of 14 is 14 times 2 is 28. So there you go. Why don't you pause this and try number 5. Well, it's a very short pause because we just did number 5. Let's try a different type of example. In a right triangle, theta is an acute angle. By the way, that symbol is theta. It's a Greek letter. We use Greek letters to represent angles a lot. And cosine of theta is 7 over 10. What is sine of the angle? Well, we could draw a right triangle and pick one of the angles for theta. Cosine is adjacent over hypotenuse. So the adjacent here is 7 and the hypotenuse is 10. So if we find the other side, the opposite side, so I can go 7 squared plus the opposite squared equals the hypotenuse squared. A squared plus b squared equals c squared. Subtract the 49. The opposite appears to be the square root of 51. All right, so sine is the opposite over the hypotenuse. The opposite is the square root of 51. The hypotenuse is 10. Why don't you pause this and try number 9? When you're done, the answers are cosine is 6 square root of 2 over 11. Tangent is 7 square root of 2 over 12. Cosecant is 11 over 7. Secant is 11 square root of 2 over 12. And cotangent is 6 square root of 2 over 7. There are two special right triangles. The first one is a 30, 60, 90. So here's a 30, 60, 90. You need to memorize this one. The shortest leg is 1, the hypotenuse is 2, and the longest leg is square root of 3. So it's 1, 2, square root of 3, where the shortest side is opposite the smallest angle. 45, 45, 90. Its sides are 1, 1, square root of 2. Because if the two angles are congruent, then it's an isosceles triangle. I need to memorize these two. They can be used to find sine, cosine, and tangent of 30, 60, and 45 degree angles exactly with the square roots. And those are very common angles, so they can be useful. Let's try a different type of problem. Let's use this diagram to solve a right triangle. Solving a triangle means that you find all the unknown sides and angles. All right, if B is 60 degrees and A is 7. Well, the first thing we can do that's really easy is A would have to be 30 because the three angles add up to make 180. So A would be 180 minus the 90 degrees minus the 60 degrees. So you can see this is a 30, 60, 90 triangle. And if you remember from the last slide, the sides go 1, 2, square root of 3, where 2 is the hypotenuse. Why is that useful? Well, if I want to find one of the other sides, let's say I want to find B. Well, from the 60, we always want to use the things they gave us if possible. The A is the adjacent, and the B is the opposite. Opposite and adjacent is tangent. So we can say tangent of my angle is the opposite over the adjacent. But tangent of 60, if I look at my special right triangle, is the opposite over the adjacent. Which means I could cross multiply that, get 1b equals 7 square root of 3. And then to find side C, which is the hypotenuse, I'm going to work with what they gave me, the adjacent. Adjacent and hypotenuse is cosine. It's the adjacent over the hypotenuse. Well, looking at the special right triangle down here, the adjacent is 1, the hypotenuse is 2. So we can cross multiply. 1c equals 2 times 7. So there we go. We have now solved it. Found all the things that weren't known. Well, let's try another one. Let me clear all my writing so we have it fresh. This time A is 32 degrees and B is 10. All right. Side A is the opposite. Notice that angle A and side A are opposite. Angle B and side B are opposite. That's typically how it's set up in trigonometry, that each side is the same letter but lowercase from the opposite angle. Side B is the adjacent, and C is still the hypotenuse. Well, we could start by finding side B. The 180 minus the 90, or if you realize that's 90, minus the 32 gives you, 58? And then let's start by finding, side A. Side A is the opposite. Side B is the one we know is the adjacent. Opposite and adjacent is tangent. So tangent of 32 is the opposite over the adjacent. Now 32 is not one of the special angles, so that means we're just going to have to solve it using a calculator. So if I make this a fraction, I can cross multiply. And I can pull out my calculator. Go 10 times tangent of 32 is 6.25. Let's do the same idea to find the hypotenuse. Yes, you could use the Pythagorean theorem, but we rounded that answer for A. So let's use the exact numbers that we have. Let's use the adjacent and hypotenuse, which is cosine with the angle is the adjacent over the hypotenuse. Put this over 1 and cross multiply. I'll have C times cosine of 32 equals 10. That's C times the cosine of 32, so we'll divide by the cosine of 32. So C is 10 divided by cosine of 32, which is 11.79. And there we are. We solved that triangle, found all the unknowns. Why don't you pause the video and try number 33. When you're finished, angle B should be 47. Side A should be about 28.91. And side C should be about 42.39. Let's try a real-life problem now. So we know the distance between Yavapai point and Pal point, and we want the distance between Pal point and Widforce point. So on the picture it's kind of misleading. It's really this y that we're looking for. Alright, so from the angle 76, the 2 is the adjacent side, and the y is the hypotenuse. Adjacent and hypotenuse is, well, cosine. So cosine of the angle is the adjacent over the hypotenuse. So over 1 and cross multiply. And then we could divide. And use the calculator, which is about 8.27, and we were in miles. Why don't you pause this and try number 37. Find the width of the river. When you're done, you should be about 514 meters.